All right, mathematicians, here is where we put it all together. We are still going to use the balance scale to visualize this, but not only am I going to take you through one more example of solving and what your work should look like, but also checking your work. So remember, checking our work is not doing it again. It literally means we're going to find out if our solution, our answer, makes our equation true. I know that can be confusing, but when we say check your work in equation solving, we'll mean this thing that I will remind you of. So first, I'm going to solve this equation. Okay, and I have the balance scale already set up. You are hopefully very good at that at this point and solving, so I'm not going to take very long doing this. So I'm going to see that I've got 3x plus 5 equals 17. I want to take 5 away from both sides. So at this point, I'm so good at this. I'm first going to write down what I'm going to do. All right. And when I'm done with that, I'm pretty sure I'm going to end up with 3x equals 12. But then so we can see that again, I'm going to take 5 away from this side. And I know that 17 minus 5 is 12. So I'm just going to replace this 17 with the 12. And my balance scale is helping me make sure I didn't make a mistake. So it's still balanced. I'm still good. So I'm going to get rid of these. And now I have 3x's equals 12. I know to undo that multiplication, to split it up, I want to divide by 3. And I have to keep it balanced. I have to do that on both sides. So literally divide into 3 equal groups, 1x in each. And then 12 divided by 3 is 4. Again, use a calculator. That's not what this is about. If you know you need 12 divided by 3, just go double check it. So I should be able to replace this 12 with 3 groups of 4. Look at that. And I get 1x equals 4. X equals 4. And let me just triple, quadruple, see if I am right. X equals 4. So now this next step is checking our work. This will be very important when you don't have the balance scale or someone else to tell you. Right? We can see right now that x equals 4, but we want a tool to be able to do that using our knowledge, using our thinking. So remember, solving the equation means finding the value that makes it true. So I'm going to go back to having my 3. There we go. I'm going to do this. I'm going to go back to having my 3x's, my plus 5, and my 17. So when we check our work, we always start from the original equation. So I'm going to put that over here. The original equation is 3x plus 5 equals 17. I want to know if x being 4 makes this true. So I'm going to replace all of the x's with 4. And that looks like this. Over here, remember this means 3 times 4. So I'm going to use my parentheses to stand for multiplication. And that is all I am doing. I am replacing x with the 4 that I think is going to make it true. I've done the work. Okay. Here, on the balance scale, it's a little weird to model, but we can do that. We can replace every x with a 4. So let me grab 3 4s, since there are 3 x's. And replace them. So that gives me a little bit of confidence, right? We're going to still show how that looks in the work over here, which we're going to expect you to do. So now I'm going to simplify it until it becomes really obvious in the equation that it's true. So 3 times 4 is 12. I'm just going to do that one thing. Okay. And we can see it over here. That's 12. 12 plus 5 is 17. I'm just doing that one thing. 12 plus 5 is 17. And now I have an equation that says 17 equals is the same as 17, which is clearly true. So we have checked our work. When x equals 4, our equation is true.